Hey, my name is Eden, and in this video I'm gonna show you a problem of rotate element by k steps to the right. Okay, let's get starting. As you can see here, we have the given array of sequence of 1, 2, 3, 4. Okay, we want to rotate it by k steps. Let's assume the k is 1. Okay, so we want to rotate it to the right one time, but as you can see, 1, 2, 3, 4. 4 don't have anywhere to go to the right. So what it will do? What? Okay, it's go from here to here. Okay, and as you can see here, the 4 number is in index 0, and all of these numbers shifted right. So it's like that. It's shifting like that. Okay, so this is for k equals 1 for one step. Okay, so let's do it for two steps. So we already did the first step. Now we need to do the second step for k equals to 2. Okay, the first one is this. Okay, now this is the second one. So 4 is getting to index 0 and needs to be in index 1 because it shifted again. So from here it's shifted again right. So 4 came to here. So it's this. And now 4 is in index 1 here. And 3, that was the previous number, is in index 0. So as you can see, 3, 4, 1, 2. So let's do it for k3. It's really easy. Okay, so now it's 4, 3, 2. Okay, this is the first shift, this is the second shift, this is the third shift. Okay, let's do it for the k. Wait, k equals 3. I don't know why I deleted it. Okay, k equals 4. It's the same like that. They are the same. So what we know here, we know that if we have k equals to 0, it's same like k equals to 4. So what we're gonna do with this information? Okay, what? If I have a k4, I need to shift all of them to look like this. It's a waste of time. Okay, it's a waste of time. It's a waste of code. It's a waste of thinking. So in these problems, what we're gonna do is this solution. Now I'm gonna show you this solution. To use modulo. Much people scared of the modulo, but you don't need to, because I'm gonna explain you how we work with the modulo. Okay, let's assume that our length is 7. Okay, like this array. So the modulo, for example, k equals to 3, as you see here. So 3 modulo 7 is 3. 3 times to shift. Okay, 6 modulo 7 is 6 times to shift. 7 modulo 7, as we saw here in k equals to 4, is 0 times to shift. Okay, but when I do 8 modulo 7, it's 1 time to shift. Okay, it's just like we have k1. Okay, so 9 modulo 7 is 2 times. But what happened if we have 13 modulo 7? It's 0 time to shift. Why? Why it's 0 time to shift? Why? Because we are getting back to this form. We are getting back to this. Okay? As I show you here and here. Alright? So this is the modulo trick for the rotate. Okay, this is a trick. You don't must to use it, but it really can help you with the complexity or something like that. Okay. Today in this video, I'm gonna show you the bad complexity solution of this problem. But in my next video, I'm gonna show you the trick of this solution, how to rotate numbers. You can rotate bits or something like that with masks and everything else, but now we rotate numbers, okay? Every problem has its own trick, and you don't need to learn the trick, but you will get used how to think, okay? So now I'm gonna teach you the big time complexity, okay? And the next video I will teach you the real trick of this problem that makes it medium difficulty. Okay, so let's get started. So we know that k modulo the length is the times that we need to shift. So this is clear now, okay? So now I'm going to explain you the code, okay? By the code, how to do it, and I will explain everything now. Now we get through the code, okay? As we said earlier, k modulo num size is length, so k is 2. The shift times that we want to shift is 2 times. So 2 modulo the length is 2. We shift 2 times. So k is equal to this, to 2. Okay, 2 times to shift. And num size is the length, as we said before. Don't get confused. We take the earlier sequence that we look together, 1, 2, 3, 4. And we want to shift it 2 times. You see, we want to get to this sequence 3, 4, 1, 2. Okay. I don't want to tell you about G. I will tell you later about it. But I is starting from the point that we want to shift from. Okay, the last place that we want to shift from. So we shift for the first time for getting here, and after that we shift again. As we can see, we shift 4 and we shift all the numbers to the right. Okay, we shift 1, 2, 3. Now we get to this position, we shift the 3 to here. It's like an exchange, it's swap, okay? And we shift all the numbers to the right here. But how it's done? How we do it? Okay, so first of all, we make j equals to g. What is g? G is equal to 0, okay? And every time that I is advancing, I is this, the last place that we are shifting from. Every time that I is advancing, so j is advancing too. So this is j, okay? If I is getting shifted right, so j is getting shifted right too, okay? So j is equal to g eventually. Okay, so I did it just for debugging. Don't look at it. So we are making the swap right now. So temp is equal to nums in place of j. So it's just like we make temp equal to 1. 1 is the number that is inside the index 0. I just get inside the code with you with an example, and after that you will understand better the code. Okay, so nums j is equal to nums I. What that means? Okay, it means that the place of I, the nums I, is 3 now. So it's just like 3 is equal to nums in index 0 because we are in index 0. So 3 is gonna be here now. Okay? So it's need to be like that, but I just go to this solution. So right to this solution. I'm not getting through this solution. Straight to this solution. I don't need this. Why? Why would I waste time for that? Okay? So I place the 3 here, and now I'm getting inside to the second loop. Why I'm getting inside to the second loop? Because I want to shift the numbers right, as we said before. So T is our, I can call it temp, okay? It's temp 2, it's like temp 1, temp 2, okay? T is equal to nums j in place 2. So it means that we are getting this number 2, okay? Because now this one is 3 and I want to get this. And num in place j plus 1 is equal to temp. But temp, as we said before, it was 1 that placed here. So now we place 1 here, and j plus 1 is equal to temp, and temp is equal to t. So t is this 2. So now we are getting the t value is 2 because it's j plus 1 is 2. So as we mentioned before, this is 3. So 2 get inside the temp, and nums, and now we are finished with this iteration, and we are advancing j plus, and we are doing j equal to 1 now, as I did here. And now t equals to j plus 1. That means that we are getting the number 3, okay? But it's the last iteration, so we are not going to use it eventually because t is not used, not in this loop, in the last iteration, and not in this loop because temp is destroyed, this temp, okay? So in the last iteration, this code is not doing anything, okay? So nums j plus 1, that means that the index 2, okay, that 3 was stored. You see 3 is still here. We are getting inside this value 2. So 2 is here now, and it's getting inside where the 3 was in. So and after that it's doing temp equals to t. T was the 3 number, but as I said before, it's not doing anything, and it's advancing j plus plus in the end, and j is not less, it's equal to I. So we are getting outside this loop to the for loop. We are advancing I plus plus, so I is now pointing to this index, to this value of 4, okay? So, and j is advancing by 1, so j is equal to 1 now. So it means that if g is advancing by 1, so j is advancing by 1. So this is j is pointing to here. So I is pointing to here, okay? We are in the end. We are almost in the end. This is the last iteration, okay? So, wait. So now we are in the last iteration. We are getting inside this for loop again. So I is advancing by 1 and j2. So I meant g, because j is equal to g, so g is equal to j. So j is plus plus, so now it's pointing to here, and this I is pointing to here. It's our last iteration because this is the length, and I, and this is the condition, so I is less than num size. So we are going to swap between these two, and 4 going to be here, and 1 is going to shift right. So as we see here, we placed the 4 inside here, we swap, we exchange with 4 with 1, and 1 is going to be shifted right by this loop, okay? Let's getting clean this, all of this, okay? So as we said, j is equal to 1, so j plus 1 is equal to 2. So this is the index 0, 1, 2, 3. So now the index 2 is getting inside this t value. Temp is 1 because we took it from here, because j is equal to 1, and this is the temp value from the outer loop, okay? So 1 is getting inside here and to j plus plus, but we are override this, and 1 is here now. But we need to take this, the value of 2, what we are doing with the value of 2. Now I tell you what we are doing with the value of 2. We are getting to the next iteration of the inner loop. So t is equal to nums j plus 1. That means that it will take the 4 number, but as I said before, the last iteration of the inner loop is not influencing at all for our temps values. So we are taking the temp value from before, that is 2, and getting inside it to the j plus 1. J plus 1 is now in index 3. So 2 getting inside to 3, to index 3. So let me write it again. This is index 3 and getting inside the 2 value. And that's it. It swapped. Thank you. Bye bye. And so in the next video, I will show you how to do it with the trick, as I said before. And this complexity is O n multiplied by k. So I can do it like that, okay? So it's eventually ON complexity. Okay, something like that. So wait for my next tutorial, and thank you for watching, and please subscribe. Thank you. Bye bye.